Hey, ladies and gentlemen, welcome to our even and odd notes for functions. So we're going to talk about what does it mean for a function to be even and what does it mean for a function to be odd. So this isn't like, sorry, let me mess around with my tools. I'll talk while I'm doing it so it looks professional. But this doesn't necessarily mean even and odd, like 2 is an odd number. No, it's not. It's an even number. 1 is an odd number, 2 is an even number, 3 is an odd number, 4 is an even number. It's kind of to do with that. It's related, but we're talking about for functions. So there's a couple of properties we need to learn. There's actually sort of a third option, but we'll talk about it when we get there. Okay, so we're looking at even and oddness of functions today. Just as a preview, this is actually an even function. This is an odd function. And you're like, oh, I can kind of already see why, right? You can probably guess why. But I'm going to teach you the actual definitions and kind of explain them to you the way a regular high school student would understand, because the definitions are kind of for people who do math. Okay. All right, let's draw something just for fun. There you go, smiley face. And a flower. There you go. All right, vocabulary. So we're going to start by talking about an even function. This definition is like out of a math textbook. So it says if a, or I'm sorry, excuse me, I can't read. A function is even if f of x equals f of negative x. So that's the only difference, is this little negative sign right inside there. This definition probably doesn't mean a whole bunch to you. So what we're going to do is we're going to look at this example f of x, and we're going to see what does it mean to be even and what does that do for us. Okay, so let's start by breaking down this definition, and then I'll kind of explain it to you in layman terms. Okay, so it says f of x equals f of negative x. So equals means they're the same. Whatever we get, it should be the same number both times. The only difference here is the x and the negative x. So anytime you don't understand what x is, just make up a number and then let's see. So let's say x equals, my favorite number today is 7. Okay. If I replace the x with 7, what this says is f of 7 equals f of negative 7. So what this means is if I plug in 7, I should get the same value as if I plug in negative 7. So if I plug in a number, if it's positive or negative, that shouldn't matter. That's what even functions are. So let's look at our example function here. Let's pick a number a little smaller than 7, just because double-digit numbers are scary, you know. Let's pick like 2. So if we do f of 2, we're going to plug the 2 into all of our x's. So we're going to have 2 squared plus 3. 2 squared is 4 plus 3. So we get 7. That was planned. All right. Now we're going to plug in negative 2. And we want to know, are we going to get 7 again? If we do, it's even. If we don't, then it's not even. So if we plug in negative 2, we're going to get negative 2 squared plus 3. Because the negative is inside the parentheses here, this means negative 2 times negative 2. A negative times a negative is positive, so it turns positive into a 4. Bring over our plus 3, and we get 7 then. Okay, so because we get the same number, they're both positive 7, that means that this is even. Now, technically, you would want to check more than one point, like 2 and negative 2. You'd want to check like 2 and negative 2, 3 and negative 3, 1 and negative 1. You'd want to do a couple because we might have just gotten really lucky and guessed one where this happens to work out. But this is an even function. I made it that way when I wrote the notes. Okay, so all even means is if I plug in a number and get something, when I plug in negative of the same number, I should still get the same answer. Okay. You're going to look at this graph here and say, Barn, why did you put a graph? Explain this to me. So this graph is going to be instructive because you can tell if a function is even or odd just by looking at its graph. So let's go peek at a graph, and I'm going to break down what are the qualities of an even graph. So if a graph is, or if a function is even, when you graph it, a couple of things are going to be true here. If a graph is even, what you can do is take your whole graph, and if you fold it on the y-axis, the left side of our graph is going to look exactly like the right side of our graph, just flipped. So if I took this thing and mirrored it onto that side, it would look like, let me just change colors. It would look like this, and it would overlap it exactly. So if we can fold it on the y-axis and both sides match, it's even. Okay, so even functions have the same output if the input is positive or negative, and if we flip the graph on the y-axis, the left side should be mirrored from the right side. That's an even function. Okay. Let's go look at odd functions. So we have another pretty confusing definition here. It says a function is odd if f of negative x equals negative f of x. So let's go ahead and do our trick, and let's pick a value for x so we can maybe understand this a little better. Let's say x equals 2 this time. So this statement becomes f of negative 2 equals negative f of 2. So what this is telling us is if I plug in the other sign of whatever you want. If x is 2, you plug in negative 2. If x is 4, we plug in negative 4. Whatever it is, plug in the opposite sign. When we plug in the opposite sign, we're going to get whatever f of 2 is, but with a negative in front of it. So what this is telling us is if we plug in the negative of the number, we're going to get the same value, but negative. Okay, so if f of 2 equals 7, if our function is going to be odd, f of negative 2 would be negative 7. So plugging in the opposite sign for the input gives you the same output, but with a sign change. That's what makes it odd. Okay, so here is our example function that we want to look at. Let's test to see if this thing is odd. And we can pick whatever number you want. Don't pick 0 just because it's a little weird, but just pick an integer that you like. So let's try 1. So we'll do g of 1. Right? We don't need to make it harder than it has to be. So this is going to be 1 cubed. So 1 times 1 times 1. Right? That's what cubed means. Minus 2 times 1. Come on. All right. So this is going to be 1 cubed minus 2 times 1 is 2. Oh, sorry, I have the wrong pen. Sorry, I'm new to being a YouTuber. So 1 minus 2, this is negative 1. Now if we plug in negative 1, this is going to be negative 1 cubed. So that's going to be negative 1 times negative 1 times negative 1. So negative 1 times negative 1 is 1. Sorry, this is difficult. That's 1. And then times another negative 1. This is going to be negative 1. Minus 2 times negative 1. This will be positive 2. So this is going to be negative 1 plus 2. So we're going to get positive 1. So we can see we got the same number, but they are opposite signs. Okay. Let's go ahead and talk about graphs and how the graph can help us figure out if something is even or odd. If our graph is odd, which this one is for our example, what that's going to mean is a couple of things. Let's go ahead and write them down. Odd if. So here's kind of our checklist for if it's odd. The first thing you need to look for is, does it go through the origin? Okay. Every single odd function must go through the origin, because if we plug in, let's say, g of 0, the plugging in the negative input must still work. So g of 0 must equal negative g of negative 0. But because negative 0 is not a thing, sort of, g of 0 must equal g of 0, and it must equal 0. So it has to go through the origin, otherwise the 0 point kind of doesn't obey the odd rule, the odd definition that we learned up here. So it has to go through the origin. Okay. Excuse me. Sorry, let's try that one more time. All right. The second thing that our graph has to do is it needs to have rotational symmetry. So what that means is if I take this graph and I rotate it 180 degrees, so I'm going to turn it that way 180 degrees, it's going to spin all the way around. If I rotate it 180 degrees, it should look exactly the same after I do that spin. If it does, it means it has rotational symmetry. So if I take this and I rotate it around 180 degrees, you can't tell the difference between that graph and that graph, besides that your numbers are upside down, the little 2's on the axis. But because the graph itself has the rotational symmetry, so if I rotate it, we can see, if I drew a little better, these would line up perfectly. It has rotational symmetry. That tells us that this function is odd. It has to do these two things. Okay? So we can either plug in values and make sure we get the opposite sign answer. So if I get 7 when I plug in a number, I should get -7 when I plug in negative that number. Or we can graph it, make sure it goes through the origin and has rotational symmetry. Okay, let's go look at a couple of examples. I'm going to teach you a couple of tricks that'll help you remember which ones are even and odd, or determine without having to do all the hard work. Okay, so let's talk about some patterns for polynomials, just because we can do all of these without having to plug in any numbers or graph anything. So for polynomials only, that's things like 3x squared plus 2x minus 7. It's just coefficients, and then variables with integer, meaning whole number, like 2, 3, 4, 5, with integer exponents. No 1/2, no absolute values, no square roots. Those are not polynomials. Polynomials are x squared, x to the third, x to the ninth, things like that. So for a polynomial, we're going to use a pattern to determine if a function is even or odd. And I'm going to go down here just a little bit so I have some room, and we'll come back. So if all, and this is important, you need to like put stars on the word all, or like flames or something. I'm bad at flames, but you get the idea. All is super important. If all of the exponents are odd, the function is odd. Okay. So if I have x to the 9th plus x to the 7th plus x to the 3rd plus x to the power of 1, because our exponents, so the 9, the 7, the 3, and the 1, are all odd numbers, this function is odd. Okay. If I put like a 2 here, we don't care about the coefficients. All we care about are the exponents. The big numbers in front of the variables do not matter. Only the exponents. Okay. So if a function's odd, if all the exponents are odd, just think for 5 seconds, right? Let's take a breath. What do you think makes things even? Go ahead, say it out loud. Impress your parents. Oh, good job. I knew you guys could do it. If all of the exponents are even, the function is even. Okay. So let's talk about a couple of exceptions really quick. So x squared plus 2, right? We're going to say, is this even or odd? Let's call this f of x. Okay. So let's look at our exponents, because that's the thing that we really care about right now, or just the exponents. This exponent is very obviously even, right? 2 is an even number. But this 2 here, you're going to go, oh, well, 2 is an even number, but this is a coefficient. This isn't an exponent. So what we need to look at is the invisible x here. There's an invisible x, okay, and it has an invisible exponent. This invisible exponent is 0. So if there is no variable, it's an invisible variable with a 0. 0 is an even number. So numbers by themselves count as even. Okay. And just so we pointed out, in case you didn't really notice it here, if you have a variable without an exponent, sometimes you'll see it written like that, just 2x. If you don't have your variable, there is an invisible not variable. If you don't have an exponent, there's an invisible exponent there, and it's an invisible 1. And 1 is an odd number. Okay. So if all of our exponents are even, it's an even function. If all of our exponents are odd, it's an odd function. Remember, numbers by themselves count as even. If we have a variable without an exponent, it's the invisible 1. Okay, so let's go look at our functions and try and figure out, are these even or odd? So if I look here, we're going to look at, remember, just the exponents. So this is an exponent of 4. This is an exponent of 2. 2 and 4 are both even numbers. So without having to plug anything in or look at any graphs, I can tell that f of x here is even. Okay. If I come over here to g of x, we have an exponent of 3. I don't have an exponent on this x, so we know it's the invisible 1. 1 and 3 are both odd numbers, so this would be an odd function. Okay. If we look at k, 5, we don't care about coefficients. That's not important. The exponent here is even. And this number by itself doesn't have a variable with an exponent. So remember, it's our invisible x to the power of 0. And 0 is even. Okay. Now you're going to say, Mr. Barton, what if there's a mix? So if we look at h of x, let's pretend there's a 2 here. I have 9x to the 9th minus 2x squared. So this is odd. This is even. I have a mix of them. So is it even? Well, no, it's not even, because all of the exponents have to be even. Is it odd? No. All of the exponents have to be odd, because it's not even and it's not odd either. We say that this function would be neither, whoops, there's an R in neither, neither even nor odd. It's not either of them. Okay. Last thing I want to talk about are just weird functions that trick's not going to work on. The polynomial trick will get you most of the way through your homework, but there's a couple weird functions, so we need to know, how do I check them if that trick doesn't work? So here are a couple of functions we can look at that our pattern isn't really going to work on. Is 1/2 an even number or an odd number? Well, it's not either technically. So this pattern of just look at the exponents doesn't work anymore because our exponents don't fit into the even odd categories anymore. So we have to work a little harder. When you have weird functions that aren't polynomials, you do need to just plug stuff in and check. So let's go ahead and just pick a nice easy number. If it's going to be even, we expect if I plug in a positive and a negative, we'll get the same number. If it's odd, we'll expect same number, opposite sign. Okay, so let's look at f of x here. We have x to the 1/2 power plus 1. A 1/2 power, in case you forgot from last year, is the same thing as a square root. So we could rewrite this as the square root of x plus 1, and make sure that plus 1 is outside the square root. It's important. Okay, so let's go ahead and just plug in some numbers that are easy, and we'll see what happens. So let's do x equals 1 and x equals negative 1. So if I plug in 1, we have f of 1 equals the square root of 1 plus 1. And this is the principal square root. So don't do any of that plus or minus business. Just square root of 1 is 1. So this is 1 plus 1 is 2. Okay. Now we plug in negative 1. F of negative 1 equals the square root of negative 1 plus 1 equals... Now we need to think back to everything we learned last year. Square root of negative 1, you can't take square roots of negatives. And if you force it, this is imaginary. So this is an I plus 1. So our answer is 1 plus I if we write it in standard form. We get a complex number. So now you're going to say, so is it even or odd? Remember, if it's even, we should have gotten the same number both times. I didn't get 2 both times. So it's not even. If it were odd, we get the same number, but negative. We didn't. We got a totally different thing. So it's not even, or I'm sorry, it's not odd either. So because it's not even and it's not odd, it's neither. Okay, so the square root function is neither. Let's go look at a graph just to kind of see why. So here is our graph of that exact function up above. So this is the square root of x plus 1. If it were going to be even, remember, it would need to be mirrored across the y-axis. So if I draw my y-axis, this side over here doesn't match this side over here. They're not mirrors of each other. If I flip this across my y-axis, it should look like that. But this isn't over here. So because when we mirror it, it doesn't land on top of itself, you can tell it's neither by looking at the graph. All right, let's go do one more example just to kind of make sure you have everything down, and then we're going to go ahead and say that's great, and you guys can work on the assignment you have posted for today. So let me just clean up this area really quick so it's a little more readable. Whoops, that's not what I wanted. Just clean that up a bit. All right, so we're going to look at this g function now, and we want to know, is this one even or odd? Again, x to the 1/3 power, we could write this as the cube root of x, and then plus x, so plus x at the end. Now, we don't know what this looks like yet, and we can't look at the exponents because they're fractions. So we have to plug numbers in and check, do I get the same number both times for even? Do I get the same number but opposite sign for odd? Or is there no pattern and it's neither? So we'll plug in x equals, we want to be able to take this cube root, so I'm going to pick 8 because it's a nice number I know the cube root of. And we'll do x equals -8 to check. So when we plug in 8, we have g of 8 equals the cube root of 8 plus 8. The cube root of 8 is 2. So 2 plus 8 is 10. Now we're going to plug in negative 8. G of negative 8 equals the cube root of negative 8 plus negative 8. So the cube root of negative 8, if you type into your calculator, you'll get negative 2. That's the correct answer. And then plus a negative is the same thing as minus. So this is negative 2 minus 8. This is negative 10. So we can see we got the same number except with a minus sign in front. That's going to tell us that this is an odd function. If we were in college or you were getting your PhD or someone were paying you $100,000 a year to check this, you should test more than 1 point. But you're in high school, so right now 1 point's probably good enough. Okay. Let's go look at the graph just to make sure it looks odd, and then we're done. So if we look at this graph, we can tell two things we have to check. Does it go through the origin? Yeah, right there. We've got a point at 0, 0. The other thing that kind of tells us that it is odd is if I take this graph and I flip it 180 degrees, I rotate it 180 degrees, it should look exactly the same as the original graph. So if I go ahead and rotate this, except for it moves a little bit, you can't tell the difference. It looks exactly the same. So it looks pretty odd. It meets all the odd requirements. When we tested our point up here, it did odd stuff. So it looks like an odd function to us. It looks, I'm confident saying that's odd. So there we go. There's your notes. If you have any other questions on even or oddness, or I went too fast, or it's just too much writing and I'm not being clear, then hop in the WebEx, go say, Mr. Barton, you're not a great teacher. I need you to explain this again. And I will be happy to explain it to you again. If you feel like you got it and you want to go ahead and try it, go ahead and go over to your assignment and try a couple of problems on that. If you're getting them wrong, then hop back in the WebEx and say you need help. All right. I will see you guys in the next video. Don't forget to like and subscribe. Don't forget to slide a bunch of money under my door once you get back to school. Make sure you tell your parents to tip. Have a great day, you guys.